Good afternoon and welcome to Design Master Training. My name is David Robison. Today we're going to be looking at the instance edit command in Design Master Electrical for Revit. If you're attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497 and our email address is support@designmaster.biz. So we are looking at the instance edit command, which is here on the ribbon. And what this command does is it lets you make changes in Design Master to specific items in your project. So you can run instance edit, you can select a device, and then we're going to open up this instance edit window. And this is really for branch circuit devices, light fixtures, motors, mechanical equipment, things like that. If you run this command and you select a electrical equipment, that we view as a panel. And so we'll actually open up our panel edit command. So as an example of that, if I've got my power plan here, we've got some panels. If you run instance edit and you select a panel, we're actually going to pull up the panel edit command. So it's another way you can get to panel edit. If you want to edit a specific panel, you can run instance edit, select that panel, it'll open this up. But the panels we're dealing with in this command in the panel edit, which is here, the instance edit is really for your branch circuit devices. So I'm going to do instance edit, and we're going to take a look first at this cooling tower here. If you pull up a device where you haven't specified anything at the family level for it, you are going to get an instance edit that looks like this. So you can't actually specify information at the family, and then the instance edit will work a little bit differently. And we'll look at that in a moment. But if you haven't done any of that, if you haven't updated your families to have any Design Master information in them, which is totally fine, this is what you get. So we don't have anything else to work with, so we kind of have to assume a bunch of stuff and give you maybe more information than you otherwise would need. So this is just a generic branch circuit device. We're telling you a little bit about the family. This is just kind of reporting information about it. And then we have the option for the circuit description. And this is how this device is going to be labeled in the circuit in the panel schedule. We can have it pulled from the family. In this case, it's just going to pull the load name, or we can overwrite that in the instance. This assumes that you are using Design Master for your circuit descriptions. That's an option in your project options. So if you go to project options, and we have in here the circuit description method, we have two options. You can use your Revit circuit descriptions or your Design Master circuit descriptions. So if we change it back to using Revit and we run the instance edit, you'll see that the circuit description, it says controlled by Revit. So we can't change that anymore. You're saying, I don't want Design Master to do my circuit descriptions. I want Revit to do it in Revit's manner, which is, you can do it that way. But then you're not doing it through Design Master anymore. Our circuit description has a slightly different kind of way of handling the circuit descriptions from how Revit does it. So people have different preferences. So if you want to use our descriptions, you do need to turn it on. And then when we run instance edit, you have the option for where the circuit description is going to be pulled from, either from the family, which is kind of the default setting, or you can override it. So this way we could come in here and we could call this cooling tower number 1. And what this will do is that this is going to push this circuit description into the circuit for us automatically. And it's going to take that custom description. So if I run the circuit edit command with that selected, it'll pull up that circuit. And you can see that that description is matching what we just typed in there. And then if we go back and we change it, this will update. So if we run instance edit and we just call this cooling tower, again, in the circuit edit command, that's going to update. And that's also going to then push to your panel schedule as well. So that lets you at each individual device set a specific circuit description. You can also set it in the family, and then you can set stuff in the circuit as well. But this is how at the instance level, you can set that circuit description. We display the load. Again, that's just reporting information from Revit for you. Then you can specify whether you need an isolated ground on this device or not. and that will then push into the wires. So by default, it's going to be no. If we set that to yes, and we look at it in the circuit edit, we now have an isolated ground being included. So that's just an option for devices that need that. The next set of options are for your graphics on your single line diagram. We have a setting for the overcurrent protection graphic, and then a setting for the feeder ID. By default, it's going to just use, it says family default. The family doesn't really have anything set, so it's just using kind of your project defaults. So by default, the overcurrent protection is going to be based on what it's connected to. So the panel has a setting for the downstream connections, and it'll use that. And then you can also override it. And then we also have the feeder ID. So by default, it's going to use whatever the ID is with the group. We can also override that and set a specific feeder ID graphic. So if we take a look at this on the one line diagram, here's where I have it inserted. It's currently got a breaker, and it has the hexagon ID. Those are the defaults that exist for that. If we run the instance edit and we make a change, I'm going to change it to a fused switch, and we are going to use an oval ID. Now it is going to use those graphics on the single line diagram. So you can set those up ahead of time, and then when you make the connection, it'll put in those graphics automatically for you. So if you want to override it, you can for specific instances. Below those settings, we have a toggle for showing it on the AutoCAD one-line diagram. This is a bit of a historical artifact at this point. We've tried to move all of our single-line diagrams to Revit. We used to do them in AutoCAD. That functionality still exists for certain people who like to use it. It's going away, but we haven't quite gotten rid of it yet. So if you are doing your single-line diagrams in AutoCAD, you can choose whether this device should show up there or not. So basically for your large motors, you want to export those. So you would set this to yes, and then that'll export to AutoCAD if you're doing your single line diagram in AutoCAD. If you're not doing your single line diagrams in AutoCAD, please don't start. Use our single line diagrams in Revit. Everything will work better. No need to go learn something that's going to be going away. But if you currently do that, that's where you can toggle those on and off. Then the next settings are for sizing the breaker and the wire to the piece of equipment. So you can specify your either FLA or branch circuit selection current. We kind of put that in the same field, your MCA and your MOCP. So you can specify what those values are if you have them for this device. I'm going to do a 60 amp MCA, 100 amp MOCP. So that just specifies those values. Then we can use those to size your overcurrent protection and your conductor. So I want to size my OCP based upon that MOCP value. And I can size the conductor based upon the MCA. Click OK. And now if we pull this up and look at it in the circuit edit, we have, you can see a 100 amp breaker, but we have a 60 amp wire being used for that circuit. So that's where you can specify those values. They also get pushed to the device as a Design Master shared parameter. So if you select the device and look at properties, and we go down to the bottom here, we've got the equipment FLA, MCA, and MOCP. So those values that we've input are now output as shared parameters that you can then do scheduling with. So if you want to schedule based upon those, you can input them with the instance edit and then get those into your schedules. There are a couple options here for the OCP trip and the conductor sizing. So by default, you can size it based on for the OCP, you can size it based upon the load. So there we'll just take the load, we do 125%, and that's our breaker size. We can size it based upon the MOCP. And we can see over here, we have NEC references. So this is the section of the NEC we're trying to model with this specific selection. So if you have your NEC and you're like, okay, I'm sizing a motor and I want to use this, this is to hopefully get you linked up to how we're trying to model that. We can also size it. There's a section for basing it on the MOCP and the branch circuit selection current. There's two different options depending on the type of motor compressor. So we have those two options because essentially we just need to tell us which column of the table that you want to use from the NEC. Then we can size the overcurrent protection for motors based upon the FLA. And again, there's just a couple different options depending on the type of motor. So you just specify that here. And then you can also just specify a specific overcurrent protection size. You can say, okay, I want a 30 amp breaker. I don't want it calculated. Just please give me this size breaker. And you can do that. Then we also have the conductor size. We have the size automatically. And what this will do is it depends a little bit upon actually your overcurrent protection sizing. So the standard sizing for the wires is going to be based upon the breaker size. So we'll set the wires to match the breaker. If your overcurrent protection is one of these motor choices, we will actually size the wires automatically based upon the load. So you'll end up with slightly smaller wires because motors work a little bit different because you oversize the overcurrent protection, the breaker, but you don't need a wire that big, but you need it big enough for the inrush current so it doesn't trip, but you don't need wires that big. So the motors, the wires are sized a little differently, and so we have that happening automatically. Then you can also tell us that you want to size it to be based upon the MCA. You can size it based upon the branch circuit selection current, or you can just specifically say, rather than for the size automatically, you can choose which of those options. Size it based upon the load, size it based upon the breaker. So if we're not sizing it automatically using the one you want, you can come and just tell us which one you want to size it automatically. So it's still automatic, but using loads or breakers as necessary for your device. And finally, you can specify a specific wire size. So you just tell us, this is the size wire I want to use, and it will use that and stop asking you questions or trying to guess. So those are the options that you have for your breaker and your wire sizing. And this is what it looks like if you have nothing set up in the family. So if I go take a look at a receptacle, it has the exact same set of options. And some of these options aren't as applicable for like a receptacle. It doesn't have an MCA and MOCP, which is why we have all the NA options so that they're just kind of ignored. If you specify these things in your families, we then get a slightly different instance edit. So I've got this cooling tower and I've set it up as an equipment connection here in the family. I'm going to load this into my project. Then I also have my receptacle. I have this specified as a just branch circuit device other, not an equipment connection. So it's just a standard branch circuit device. Load that into the project. Now when I run the instance edit, we're going to get different windows. So if I edit this cooling tower, it now says, okay, it's an equipment connection. So it's not just kind of this generic other. And then we're going to pull those values that we set in the family in as our defaults. And so it has just slightly different defaults because it's pulling from that family. And then also, since it is an equipment connection, we are displaying the motor settings, the motor multiplier and the XR ratio that are used for your fault calculations. Since those are specified in the family at that point, we actually have them and we can show them to you. So this looks pretty much the same when it's an equipment connection because that has kind of the full range of information. If I run the instance edit and select a receptacle, it has the full range. Again, it doesn't add that additional motor information there. When in the family edit, since it's a receptacle, we don't let you set most of that information. But in the project, again, it's all going to be by default not set, but you can still override it if you do need to. So even if you set it in the family as an other for the branch circuit device, you can still override it and add that information that you weren't adding at the family level. So that's what ends up looking like there. That is it for the instance edit command. So are there any questions on the instance edit command or anything else related to Design Master in Revit? Question, can you take all this information into your template? Yes. So you can load all this up into your template so that when you start a project, it all has all the information in there. So you can open up your template, run our stuff and get your information, get your shared parameters. If you need our shared parameters, we ship the file. It's in our customization folder. To get to the customization folder, if you go to your user options, we list where the customization folder is. This is where all of our stuff is. You can choose a new location. You can also press open, and that'll just take you to it in Windows Explorer. And then these are all the shared parameter files, and then all of our families. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.